All right, so let's read what's going on in this one. This was the related rate question, if I'm remembering this. All right, a cylindrical barrel with a diameter of 2 feet, and that's not changing. That's going to just be 2 feet. Is collecting rainwater. The rainwater drains out through a valve that isn't shown at the bottom of the barrel. So this has like a hole in it, and water is also coming out. The rate of change of the height of the water with respect to time is dH dt. That's given by this. We have feet, we have seconds, and then they give you the formula for the volume of a cylinder. All right, so let's see what's going on in part C. At time 0 seconds, the height of the water is 5 feet, so that's an initial condition, 0, 5. Oh, use separation of variables to find an expression for H in terms of T. So this is, I think they threw the related rate in here. I think that was part A or B. And then this is your differential equation. It is separate, integrate, put plus C, plug in your initial condition, and then solve, in this case, for H. All right, so we're going to start with this, dH dt equals -1/10 square root of H. So we're going to separate the variables. I'm going to divide the square root of H to the other side. So it'll be 1 over square root of H dH equals -1/10, and I'm going to multiply over the dt. So I want all the h's to be on this side, all of the t's to be on this side, and then we're going to do the antiderivative. So we're going to do the integral for both sides. I am going to take a step and rewrite this though. Square root means to the 1/2 power, and since it's in the denominator, this is h to the -1/2. So I'm going to just take a second and recopy that. I know that's a little bit of rewriting there, but just to fix that exponent. So h to the -1/2. So antiderivative, we're going to add 1 to the power. So -1/2 plus 1 will be +1/2. And so I need a 2 out front. And then this antiderivative will be -1/10 t, and then plus a constant. And then we're going to plug in the initial condition. So when time is 0, h is 5. So if we plug in 5 over here, that's 5 to the 1/2, that's square root. So 2 square root of 5. Time is 0, so that would just be c. That just is your constant. So what you're going to do is recopy this step exactly, except instead of plus c, you're going to put plus what you got for c. So plus 2 square root of 5. And then the last step is to get h by itself. You want to do as little work as possible here with messing with this. We want to divide the 2 over. So honestly, I would just do this, just put the whole thing over 2. And then to get rid of the square root, we're going to square. And so you'd want to just square the whole thing. And I mean, literally just do that. You want to do as little work and simplifying as possible, because if you mess with it and make it wrong, then it's going to be wrong. Also, the exam's timed, so do as little work as possible. All right, let me move on to the next one, because I want to at least be able to do something from each question. If you're like, we don't have enough time, I know, this is how I've felt all semester. Like I knew we were not going to have, there's just too much in this class. All right, you look at number 5. What parts from number 5 would you like to do? This was a lot of the new integration that I think they put an improper integral in here. I don't know, I'm remembering this here, but part A, B, or C? Part A. All right, so number 5, part A. Consider the family of functions given by this. K is a constant, so that means that's some number. Find the value of k, where k is positive, such that the slope of the tangent line. Okay, so when they say slope of the tangent line, what does that make you think? What is slope of a tangent line? What should that remind us of? Good, perfect, derivative. Slope, I was hoping someone would answer. Slope of a tangent line means derivative. Like basic part of calculus. All right, slope of the tangent line, that's a derivative. of the graph of f at 0 equals 6. So what they're telling us is that the derivative at 0 is 6. So f prime of 0 equals 6. So what we're going to do is we're going to get the derivative. We're going to plug in 0 for x and then set that equal to 6. All right, so this derivative, I would write this as all of that stuff to the -1. You could do a quotient rule if you wanted, but I think this is going to be easier if we just write it as all of that stuff to the -1. So the -1 is going to come down, and we're going to have all of that stuff to the -2. And then we're going to chain on the derivative of the stuff inside, which would be 2x minus 2. And so I'm going to take a second and rewrite this. I want to fix the negative exponent. All of this is going to come down to the denominator. So it'll be negative 2x minus 2, and then all of this stuff in the denominator. All right, so that is our derivative. And so we want to plug in 0 for x and set it equal to 6. So if we plug in 0 for x, this will be 0 minus 2, so -2, but then it's -2. So the numerator would just be 2. And then down here, oh, sorry, this is all squared. I apologize. It was to the -2, so all that stuff should be squared. So if we plug in 0 for x down here, these are going to be gone. We're just going to have k squared, and then that has to equal 6. So we got the derivative, we plugged in 0, we set it equal to 6. So I'm going to multiply over the k squared, and then divide by 6, that'll be 1/3, and then square root. Now, usually you put plus and minus, but I think they said up here it was positive. Yeah, and they said for k greater than 0. So we only want the positive square root. So this is your final answer. Square root of 1/3 is k. All right, I have about 10 more minutes. Do you guys want to pick another part from number 5, or do you want me to switch over to number 6? I can probably do like a couple more parts of some stuff here. Just let me know, do you want another part from this one, or do you want me to switch over to number 6? All right, number 6. Where do I have that one? Oh, I have it on the back of this one. Okay. So what part from number 6 would you guys like to look at? Which part from 6 do you guys want to do? A, B, C, or D? If you guys aren't saying anything, I'm just going to start with A. Okay, B. All right. So letter B, write the first 3 non-zero terms of the Maclaurin series for e to the x. Okay, so we can do that. E to the x is 1 plus x plus, it'd be x squared over 2 factorial, which would just be 1/2 x squared. So let me just go ahead and write that as 1/2 x squared, because they're not going to have us go any further here. They just said the first 3 terms, three non-zero terms. All right, write the second degree Taylor polynomial for e to the x times f of x around x equals 0. And actually, I think they had you find you know what? Can I go back and do part A? Let me go back and do part A, because I think we're going to use that for part B, if I'm remembering this correctly now. Let me go back to part A. Right, the third degree Taylor polynomial for f around 0. So I am going to, of course, at this point, write this all out. So it's going to be f of 0 over 0 factorial x to the nothing. And they said third degree, so I've got to go all the way to the third one. All right, so we want f of 0. So let's see, they've got to give us that somewhere. Is this the function f? A portion of the graph of f is shown above along with the tangent line to f. Okay, so this is the graph of f, this thing that's kind of like a parabola here. We want f of 0. So f of 0 is 3. All right, so f of 0 is 3. 0 factorial is just 1, x to the 0 is 1. So this first term is just 3. All right, plus, now we want the derivative of f at 0. That's why they drew in this tangent line. Derivative is slope of a tangent line. So now I want the slope of this line, which is going to be negative because it's going down. I think it's negative 2. It looks like it's going down 2 over 1. All right, so that is negative 2 for this part over 1. So this will be minus 2x. All right, second derivative of f at 0. And now I'm going to start looking over at this table here. So the second derivative at for 0 is 3. So we're getting 3 for that. Over 2 factorial, which is 2. So that'll be 3 halves x squared. And then the last one, we want the third derivative at 0, which is negative 23 halves. All right, so this will be minus 23 halves over 3 factorial x to the third. All right, so this was part A, was writing out that Taylor polynomial. Part B, they want us to do multiplying e to the x, which is this, and we want the second degree Taylor polynomial. So we're going to multiply these together, but only to the point where we would end up with a second degree. So you only multiply the terms together until you would end up with a second degree and just don't go any further. So I'm going to finish part B down here. Sorry, I had to go back and do part A because I needed this. So we're going to multiply these together. So I'm going to distribute the 3 to all 3 of these. So that would be 3 plus 3x plus 3 halves x squared. And then I'm going to distribute the negative 2x just to these first 2, because if I distribute it to the third one, I'm going to end up with an x cubed. And it said we only want second degree. So this would be minus 2x squared. And then I'm going to multiply the 3 halves x squared just to the 1. Because again, if I go any further, it's going to go above a second degree. So that would just be 3 halves x squared. All right, and so that is your answer for B. All right, so I'm down to 5 minutes. I can probably only do one more question. Do you want me to just go ahead to C since we're right here, or do you want me to go back to any of the other ones? Or are you guys good with me just moving on? Like, since we're on this question right now. C works, okay. Oh, I just folded the paper over and it says I'm gonna have to go back and use the part found in part A. I can't fit this many pieces of paper under my projector. I miss being in a classroom with a whole board where I could write on the whole board. All right, let h be the function defined by integral of f of t dt. Use the Taylor polynomial found in part A. So that's this one. Gosh, with this question, you needed part A in order to do part B and part C. You'd better hope you didn't mess up part A. I don't really like that. I feel like that's not real fair. You end up using the same thing over and over here. All right, use the Taylor polynomial found in part A, that's this one, to find an approximation for h of 1. All right, so h of 1 is going to be approximately integral from 0 to 1 of all of this. Let me simplify this down a little bit, because if I'm going to have to do an antiderivative here, let's see. 3 factorial is 6 times 2 would be 12. So I'm going to write that as 23 over 12, x to the third, and then dx. The reason it's only an approximation is because we only went out to, a third degree polynomial. This goes on forever and ever and ever. So that's the reason it's only an approximation. But now we're just going to do the antiderivative and then upper boundary minus lower boundary. So this antiderivative would be 3x minus x squared plus, all right, I'm going to add 1 to the power and then divide by 3. So 1/2 x cubed minus, so this would be to the 4th, and then we have to divide by 4. So 12 times 4 would be 48. And then such that 0 to 1. So upper boundary minus lower boundary, if you plug in 1 to all of these, you're just going to get 3 minus 1 plus 1/2 minus 23/48. And then lower boundary, if you plug in 0 to all of that, you're just going to get 0. So this part is your answer.